have. It'd be good to have something, anything, and this is like 10 steps above something, anything. This is great. So thank you, Brad, for doing that, and I'll look forward to seeing that on the intro to the channel. So Bob Armstrong is going to introduce himself and tell us about comparing CoSy with other array languages.
Okay. One of the things that's nice with these virtual backgrounds is that I can smoke outside by just sitting here. Anyway, seeing my screen now. Everybody sees the screen like it should be, hopefully, and I'll
Yeah,
hit
we see it.
a time. Okay, I'm big enough. It's interesting. I made a announcement of this talk on the internet like this, and it was deleted in the fourth 2020 group. Wanted to comment on Big Bill Ragsdale's. One of the main uses of CoSy is, and I've got it, I think right here. This is actually all this year's accounting stuff and so forth. So the CSV conversion is very important. And there's my some of the vocabulary. CSV to list goes and just makes things into a regular list. A DT, a dictionary table using K's language, is a list of two lists. The first of which is the column names, and then the second is the and here's actually all the definitions of those words. You can see they're generally just one-liners, and there are variations on the theme. But Conor Hoekstra, who is he's got quite a, let's see, he's got 60,000 subscribers on his code report, and he's very tied in nowadays with Dialog APL. But he's definitely a programming language polyglot. I happened to bump into this his presentation of a simple algorithm in these array languages. Also, more recently, and I'll just quickly do that later, because all of these are one-line functions in these array languages. He did an even simpler problem in, Jesus, I don't know, 20 languages. Anyway, I see the first thing that I really need to do is I need these. I want to make a random array. So actually, this is my math language, which in my presentation things here, they're not automatically defined, but here are my random creation functions, and it gets down to, well, this needs at the fourth level, this random array that just somebody who's involved in fleshing out Riva did. So let me go and remove comment symbol there and evaluate that now. So I know that I have these random words. available, and the floating and the variations on things. But, and one of the things actually, there are multiple things when I go and do a demo, like I did for the Silicon Valley, or to the APL bug, the Bay Area Users Group on Thursday. But one of the things that's notable, that is nice about RPN, is you can just put a comment symbol in anywhere that sort of has a completed action, which essentially means, in my sense, that there's just one item on the stack and it gets presented. So, oh, I shouldn't have split it there, because that actually put the two numbers on the stack. There's the other one. Let me that's the parameters to rand goes and gives me. I just wanted a simple. Why did that? Oh, no. Let me redefine. Okay. Rand. Oh, okay. I don't know why that. This is one of the things is, and this comes from Apollo 11, restart on failure. And when there's so many ways in which you can write a line that fails. But that gave me 16 random numbers in the range of obviously 0 through 10. And Conor's, I should go and say, Conor's task, and I'll go and let people look at his video, scan through his video, but essentially it makes a cross array, and which is I guess well, an identity matrix. Hopefully people definitely, it's worth learning some matrix algebra, whatever you're involved in. But a cross array is one that's, well, an identity matrix is ones down the diagonal and zeros everywhere else. A cross matrix, which I don't know whether it has any uses, is one that, well, you'll see. I'll make it in a minute. But to go and make a 4x4 array, it's 4-4 take. Essentially, this is an integer list of 4-4. So here's a random 4x4 matrix, and then this is a very new word. I've only started using it, but it takes this name here. This left tick goes and just simply returns that as a name, and then this arrow to, it's actually a form of, it's value that increments the that doesn't reference increment, so it makes the makes an APL variable. And actually, if I did it at this point, well, let me go. I can, again, this ability. If I just cut off the line at this point, this is one of the things about doing things live. And particularly when I go and I've got junk on my stack here. Let me just erase all of it. Where's my, one of the things is down here when I go and, yeah, that's reset the stack. I know that's too teeny to see. But yeah, when I execute this line, I better go and I really need to, in other windows, I have rand automatically converted, but it just returned nothing. And why it bombed, don't do that. Okay. It made this matrix now. So now I have a random matrix, and which is what, is that across, is that non-zero on the two diagonals is Conor's problem. And Conor's method for making a identity matrix is simply this, which is essentially going, let me go and throw in comment symbol. So iota is a very fundamental word. The tick I goes and turns the 4 from the x86 stack, turns that into a one item CoSy list or vector, one item list. And then iota goes and essentially gives you the first n integers. And when I first learned APL, I thought, whoa, this is bizarre. But it's like the index into an address space is, I think, one of the best ways to think about it. And this is quite useful. This is essentially dupe, simply dupe, but with reference incrementing. So it just simply goes and well, it makes 2 copies of the thing and increments the references. So the garbage collection or the freeing is handled. And then this tick, of course, is the 4th brilliant notion that it just simply returns the address of the next word. So you can pass a verb to another verb simply by ticking it, and equalize this equal on integers. And this follows very much Arthur Whitney's language in K, where he has particularly he's got each and each right and each left, and so this is it'll hold. It's got 2 copies of this on the stack now, or on the stat now after the do, and this is going and applying equals, whether they're equals on holding the left one constant and for each of the items in the right. So there you get an identity matrix. I actually, and so this is his, and of course this is just simply defining it as a verb. So now I've got something that I can just, pass the parameter and say, give me an identity matrix. I don't actually like that method of doing things. Because that's doing a computation in equal on this entire n squared set of numbers to go and just, are they equal or not equal? And it really probably doesn't make any sense. But one of the things from way, way back, when I found out that APL didn't have an identity matrix, how can you have an array language that doesn't even have an identity matrix? So anyway, I like working it out this way better. So there goes. I have, rather than this be slightly different in APL, but let me throw in, I made the word fill. So this makes n plus 1, well, this, I'm working with 4, okay. I'm just doing an example. And one of the things is, in terms of going and figuring out programming, I sort of work through things line by line like this. And then I do, okay, so I've made this list that's 5 long. And again, and when I turn that, when I go in and take that 4, because indexing in CoSy is modulo, I end up with my identity matrix. And that is perhaps slightly more complicated than what Conor does. It's less computation because all it's doing is indexing the items into. So I actually went and defined my thing, and here it's just duping the thing. And this is something this is the first time or the second time that I've really used this structure, but I've wondered how can I go and have something like this and make it a constant that stayed. So obviously, and these are things that just simply no other language is at this factored, highly factored level. So of course, this is going and actually doing this immediately. And it's upping the reference counts by one. And then it comes back and it saves that as a literal. And so now I know how to make any sort of a constant that's a CoSy constant. And this I found, I think on this minimalist computing list, this is just swap. Okay, so I mean, this is dupe and this is swap. And then I'm adding one to that. And essentially what this is doing, I'm just making this the definition. So now I can go and do, let me come down here. Do I still have Matt around? Yes. Okay. So I can go and make my identity matrix and do it. Sort of inconsequentially more efficient. Incidentally, on the APL bug meeting on Thursday, there's Adam Budowski is sort of like he's the big techie at Dialogue APL now, but we ended up dominating the discussion. But he probably gave absolutely the most computationally insane method of making a identity matrix by essentially making two random float matrices and then doing a matrix division between them, and so that ends up, when you divide two identical matrices by each other, you end up with an identity matrix. But the amount of computation you've done is just insane. And by the way, it'd be very nice for somebody to implement a matrix division in CoSy. Oh, and then I also made, because actually float matrices are very much I to F, I went and actually factored that and made that. So, but in any case, skip down here, still have Matt around. Okay, so if I go and I make well, here's make an identity matrix, and we're looking to make a cross matrix. So we've got that identity matrix, and again, dupe it and reverse it, and then OR them, and I'm saving that. So there I have my cross matrix. That's what's meant by the cross matrix. So if I go and I and that, which is actually the same as min. Arthur Whitney in K just has essentially max and min, because on Booleans, on ones and zeros, min is 0 and max is 1. So the same function works on both of them, and you'll see if you remember, actually, problem is that matrix, that random matrix I created, has a 0 there. So to finish off the whole thing, quote is match. Do these two items match each other completely? So the answer is no. Okay, and that's actually the entirety of his of Conor's problem. And I want to just go and let me make, okay, that one should come out. Well, I go and make this into a word, building in these things, and notice this is the other thing that sort of is this I don't know what you want to call that, but that's the count of how many items are in a list. And this is just putting together everything like that. So now I have this word, and I do chat. Matt, I thought that I had. Let me see, Matt. This is one of the things is when going and doing demos of new code. Oh, I might have. Whoops. That should be a 1, I think. Oh, no. That's correct. There's a 0 there off the diagonal. So that one looks good, right? Yeah. Okay. And you can look Conor's definition. As a matter of fact, this may be queued up to go and show
Max, same jot equal tap.
Yeah, he's going on in the APL
or
about
jot equal self iota tally. We now basically just need to check our.
You can go through. Incidentally, this little symbol here.
These two equal. There's an operation for that in APL called match.
That's the same as my dupe. And actually, if it had something on both sides of it, then it's swap. And the thing is, the amount of crap that the APL has to go through to do those profoundly simple things, because this is one of the things that Bose, I've got this little list here of some of these things, but tick dot plus. This is another thing. C. Oh, dot plus. You know, that's the totality of I mean, this is dupe inline, and then it just does the reference increment. And this is something that blows APL or most higher level language people away. I think it did at the Lambda conference. That no other environment, no other language do you have the continuum from the very high level all the way down to the underlying hardware code. So anyway, you can go and check and look through his different versions. But I mean, essentially, this is the my total, the total definition in CoSy, and you can see it's actually simpler than what he's doing in APL there. And just as a bonus, he also has this. And actually, if I started this up, it would be. It'd come up with an ad for Kamala, all that crap. But here's his other thing. One problem in 24 programming languages. And it's quite simple. And this is actually the list that he gives. But it's count up how many negatives are there and how many positives. So there's his data, if you will. And here, I'll just go ahead. I think I've got that. Yeah. And his question is, are there more positives or negatives? And there are 3 negatives. Essentially, well, unless somebody wants, I'll this is pretty trivial. Interestingly, one of those words that I find quite useful um, in accounting is I have this word, well, these two words, and let me go and just that go I use all the time because things will come in. You go and download various accounts from various, banks and so or credit cards and so forth. And they often come in as two columns of debits and credits. And one of the things to combine the columns into things, it also you also want to go and split your positives from your negatives. So these words go and do that. This is when I put the thing into, okay, it's dupe, it's 0, is it less than 0? And then add up the number of those that are less than, swap, so you got the other copy of the thing. Okay, how many are greater than 0? Then add across those, and then min those. So you end up, or max those. So you end up with, let me define that. So there are the three negatives and which is more than the two positives. And the zeros, that's one of the things that's sort of why my split that I normally use, which just goes and throws the zeros in with the positives, is that finally one of the things is I've created this Techie Dome language in response, or Techie Dome page on CoSy, where I've got a bunch of this. There it goes. I don't know why it's got all that space there. That has probably more to do with, yeah. But in any case, I've got this, and if anybody wants to comment or even subscribe to this page, this is where essentially techie discussions of CoSy are going on now. So with that, I'll hit F11 and return control to
Well, thank you, Bob. Are there questions? I think Kevin indicated he's needed to head out. So
I'm still here, but I better leave at any moment. But questions for Bob?
was that coherent enough?
It was content. Never argue with somebody that wants to give me content.
Yeah, one of the things is it's you can look at it in detail later and like I say now, Techie Dome. And you go to Techie Dome and we can work through it there. Some of this vocabulary, but not in the some of the recent vocabulary is not uploaded to the current free versions. I got to update things, but I think you can see that it's quite competitive with other array languages, and in fact, it's far simple, more flexible. There just simply is no other environment that gives you the APL level. But again, with like Don working on FPGAs, you've got it's just simply executing in as a fourth vocabulary.
Bob? Hello, Bob.
Yep.
Bob, there was a question in the chat about your email address and your website. So if you could go into the chat and for the record, for the meeting notes, provide your email address for those that are interested in CoSy?
Yeah, go to CoSy.com and there's a click here to be added to my email. And I should mention, if anybody is in the vicinity of the Colorado Front Range, my CoSy Midsummer Mountain Mela 2024 is happening next Saturday, which is the closest Saturday to midsummer, to astronomic midsummer. It's a, if you go through, it always has the links to the previous party invites. And if you go and click back, my big parties were in Manhattan. Out here, not so many people manage to make it. But yeah, click all the way back to the Manhattan parties when I hung out with the art crowd more than anything else. And the art crowd will go to any party, any day of the week. So yeah, just go to CoSy.com and you can see down at, and that's got a link to my recent talk and actually a lot of the stuff on planetary temperature that's there, but down at the bottom, well, you can reach me through that. Just CoSy.com, short for coherent systems. Back when I had to come up with a 32-bit email address for coherent systems back in 1980. So, okay.
All right. That's good timing, Bob. Okay.
Thank you.
So, anybody further stuff? So a motion to adjourn is always in order. Let's pull a plug on the recorder.